Hey, it's Mr. Luneski here today with Unit 2, Section 2. We are going to be proving lines parallel. Last unit we talked about all these different angle relationships and we learned all of this new vocabulary. And we're basically going to revisit all of that again today. So it's almost like a little review. We're going to be looking at things slightly differently today though. You may notice the first four things we have here are revisiting all of those angle relationships, except now these theorems that we looked at, we're now going to look at what's called the converse of those things. So our corresponding angle converse states if two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are going to be parallel. So what this is saying is if I have two lines and I draw a transversal, if corresponding angles are congruent, then I can make the claim that, hey, those two lines are parallel. This seems very, very similar to what we talked about last class, except last class we looked at if two parallel lines are cut by a transversal, then the corresponding angles are congruent. So converse basically just sort of flips that around. So this lesson today, we're all going to be proving if the lines are parallel. So the alternate interior angle converse states if two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are going to be parallel. So remember, we have our shorthand for congruent. We draw the congruency symbol, and parallel, you just sort of draw two parallel lines. Alternate exterior angle converse states if two lines are cut by a transversal so the alternate exterior angles are congruent, then the lines are parallel. The consecutive interior angles converse states if two lines are cut by a transversal so that consecutive interior angles are supplementary. So remember, this is the one relationship where we don't say they're equal. This is the one where we say they add up to 180. So if that happens, then we can say that yes, indeed, the lines are parallel. So now, the rest here is just a little, this hint section's kind of a little review of what we did in the last two sections. So in a problem, if we are trying to prove the lines parallel, we are going to use those converse theorems. So if a problem asks you to justify your reasoning or explain what theorem you used, you would be using the converses if you're trying to prove the lines are parallel. If you are trying to prove that the angles are congruent or in some cases supplementary, that's when you're just going to use our angle theorems, in other words, the things that we discussed in section 2.1. When you're starting to think about these problems, anytime you get to a problem, your first immediate thought should be, what is the relationship of these angles? You should think back to that chart we talked about in section 2.1. And keep in mind that when we're solving these problems, there's really only two scenarios that we have. You're either going to set the two expressions equal to each other, or in some cases you are going to add and then set them equal to 180 if they're supplementary. So let's take a look at what some example problems would look like here. Directions tell us to find x to make m parallel to n, and then justify your reasoning. So in other words, we need to explain what theorem we used in order to make the claims that we're making. So when I get to this first problem, I want to think about what is the angle relationship of those two angles. Those are alternate interior angles. So what do I do with alternate interior angles? I set those things equal to each other. So in this problem, we just set the two expressions equal to each other and solve for x. So we'll add 14 to both sides, which gives me 86. And then when I solve for x, get that x is equal to 43. So, justifying my reasoning, what did I use to make this claim? I used the alternate interior angle converse. So it's really, really important that you have the word converse there because we're trying to make m parallel to n. So all of our justifications in these three problems should end with the word converse. The next one, what is the relationship of these angles? If I look at these two angles here, the relationship is that they are same side interiors or consecutive interior angles. So without even solving the problem right now, I'm able to justify what I'm about to do knowing that we're going to be using consecutive interior angle converse. So consecutive interior is the one scenario where we actually add them together and set it equal to 180. So this gives me 5x plus 40 equals 180. Subtract 40 from both sides. And then when we divide both sides by 5, we get x is equal to 28. So these are my two answers here. And then the last problem, again, what is the relationship of these two angles? These are corresponding because they're in the same position, top right, top right. So that is when I set them equal to each other. Divide both sides by 2, and you get x is equal to 12. So that one was pretty easy. And what did I use to justify my reasoning? I used the corresponding angle converse. So the rest of this worksheet just has some example problems for you to try out on your own, solving for the variable, and then justifying your reasoning. So you can work on that, and we will discuss it next class. Thank you for watching.